So this becomes the square root of 64x squared. And that's why I was kind of asking about this exponent stuff. So x to the 1 times x to the 1 is x squared.
Yeah.
All right. And then from here, you have to take the square root of each of these separately. So square root of 64, square root of x squared. 64 is 8. Do you remember what the square root of x squared becomes?
Just x.
It is just x, yes. That's your final answer here, 8x.
Okay.
Okay, so from here they kind of get more difficult. Let's look at number 8 next. Okay, simplify, assume that all variables are positive. So this is really the square root of 50 times the square root of x to the 11th. And the 50, square root of 50 is what I call reducing roots. So to do this, you have to make a factor tree or a factor ladder. Have you heard of that before?
Yeah.
Which one, or both, or neither?
I've heard of factor tree. It's the
Yeah. So you start with you start with the smallest prime number, which is 2, and 2 goes into 50. 2 times 25 gets you back to 50. And then 2 doesn't work, so you go to the next prime number, which is 3. 3 doesn't work with 50, but 5 does. And so you stop when you have all primes on the leaves, the edges here of your tree. You're looking for pairs. So if you have a pair means that 1 comes out. Okay, basically a 5 is going to come out. Anything that's not brought out stays in. Okay, so that it's the square root, and there's a part that's out and a part that's in. The 5 comes out and the 2 stays in. Is that something you've seen before?
not really.
Okay, so we can do a few more examples of that. That will hopefully clarify this. So let's just go with it for right now, and then we'll talk about how to reduce roots. But for the moment, just go with this. This square root of x to the 11th. There's a couple of ways that you can do this reducing this part. The first way I'll show you is that this is really x to the 10 times x to the 1. And the reason is, of course, because the bases are the same, so you add the exponents. And then this breaks apart into x to the 10, square root of x 10 times the square root of x. Do you recall what this becomes on the left here when it's even? Square root of an even number? Like
Yeah,
why was the square root of x squared x? I mean, that's true, but do you know any more than that, like what the justification for that is?
because it was x times x.
That's true. So this would be x to the 5th times x to the 5th. Does that help?
Okay. Yeah, I was kind of confused because I was thinking of the like multiplication rules with normal numbers.
Yeah, a little different with roots here. So this becomes x to the 5th times the square root of x. So
okay.
just to be clear here, like we dealt with the square root of 50, it became this stuff on the right, and then we similarly square root of x to the 11th becomes this down here. So you pair these up, like you can't just leave it kind of mismatched like this. So it's 5 square root 2 x to the 5th square root of x. And so the parts that are in the square root, they go together in the root. They go together in the root, and then the 5 and the x to the 5th, they go together outside the root.
Okay.
So if you're trying these as we go, just let me know if there's ever any mistakes, so that we can revisit them as needed.
All right.
Okay, so let's just spend a little bit of time reducing roots. Let's look at the square root of 12. That's probably the most basic square root reducing problem you could have. And again, you need to know the prime numbers 2, 3, 5, 7, and so on. So you first start with 2, and it's 2 times 6 to get back to 12. And then you try 2 again, 2 and 3. And if you have a pair, in this case there's a pair. For each pair, you bring the number out. Just one though, just one comes out. Is that clear? And then
Yeah.
if there's anything else, but it's not paired up, I meant to switch to the other color here. It stays in. So this is 2 square root of 3.
Okay.
Okay, so try this one on your own. It's not really any different than the previous one. Almost looks the same. See what you come up with.
I got 2 and how does one say this?
Square root. Square root, yeah.
Square
So
root of 5.
Yes. So the fact that it's this symbol is the root. That's the root part.
Yeah.
There's a 2 that's not written. That's the square part.
But the 2 that's in front of the
Yeah.
square root part, how would I?
That's good. You just say 2 times the square root of 5 in this case. Good. Okay. Let's keep going on the assignment, and then we can dive more into this if we need to. The next one is a perfect square root, so it's not as, not as interesting, I guess, working it out. But so excuse me. So this is akin to one that we did one just like this problem or two ago. It's like square root of a times b times c becomes the square root of a times the square root of b times the square root of c. So you can break this one up into the square root of 36, the square root of x to the 13th, square root of y to the 7th. Is
Okay.
that okay?
Yeah.
Now, the square root of 36, I think you know that one. That's 6, okay?
Yeah.
So that, again, there's a couple of ways to do this next part. The square root of x to the 13th. One way is kind of like we did in the previous problem where we make it 12 and 1 like this.
Yeah.
That's a good way to do it. But then you have to know how to break apart square root of x to the 12th. Can you tell me what that becomes?
Six x.
Yes, x to the 6th,
Yeah,
good.
6 times 6.
So that it's like because the bases are the same, they add, so you actually just cut it in half. 12 divided by 2 to get 6. That's maybe a better way to remember it. Okay, so we've tackled that. Can you try the square root of y to the 7th? That's very similar to what we just did.
I got x3 and this
So y
square
3.
root of x. Oh yeah, y3.
Yeah, that's just a minor thing, but that does matter. So so now the last part here is to just clean up. It's that you gotta mesh the stuff that's outside the root. So and you generally put the number first, then the variables in ascending or alphabetical order, and then you pair up what's under the roots together.
Okay.
All right. So the last picture is for number 2. This one looks more complicated than it actually is. Okay, so this problem here, it looks really complicated, like lots of stuff, but what it's really asking you is, what is the square root of a times the square root of a? Because notice what's underneath is exactly the same in both. And so on the right here, you can see that it's the square root of a squared, which is a.
Yeah.
So the answer is just what is under the root. 591 x to the 15th y cubed.
Yeah.
All right, so that does it for the questions you sent. I mean, we can certainly do another exercise, some more exercises on these roots, but do you want to send over some more questions for us to work on?
Yeah, I'll see if there's any more review stuff.
I mean, this is not related to factoring, so it's I hope that this isn't on your test, because it's very different than what we've been doing.
Okay, now I see some more review stuff.
Okay.
Okay, I sent him over.
Great. I'll take a look here. It's trapped in the wire. Okay, come on. Let's just waiting for something to come in here. Let me know if it shows as sent. Yeah, I'm still waiting for something to show up here.
That's weird. I'll try to resend.
There it is. Okay.
Perfect.
Always the moment when you give up is when it works out. All right. Yeah, so we got, let me just look through these. 17, 16, 15. All right, we'll work these in order. Are your tests in person? I'm sorry if I've asked, but are they in person or online?
They're in person.
Okay. So, right. So the question here is just asking you to factor, and this one is not prime. Okay. Do you remember the type that this is based on this form? 3 terms. It's got a 1 in front.
Be a the word polynomial something.
So your focus, yeah, your focus is on the last number and then the 7.
Yeah.
So you're trying to find 2 numbers that multiply to -8 but add up to +7.
Yeah. Okay, so -1 and 8.
Yes, so this becomes x minus 1, x plus 8.
Yeah.
All right, so any questions on that type? I mean, I can always give you another one like it if needed. Actually, number 9 is really similar.
Yeah, let's go on to that one.
Okay, so here is number 9. Same situation, two numbers that multiply to the last but add up to the middle.
X plus 5 and X plus 9.
Yes, you got it. All right, let's look at, just trying to debate which one to do here. Okay, let's look at 11 next.
All right.
So when you see them with two variables like this, do you remember what we did the other day?
We pretended that one of the variables was just not there.
Yes, you ignore or omit the y, and then see if it it works out.
Okay.
Again, two numbers that multiply to -68 but add up to 13.
Okay. So that'd be -4 and +17.
Yes,
For
x plus 17, x minus 4, but you got to be careful, like the fact that we omitted or
the
left out,
X.
you have to add in that. Yes. It's easy to forget to do that, so I don't know what to suggest. Because I'm the type to probably forget that, even though I say to not do that. So let's go. I guess we're just doing these in the order they've arrived in. Any questions on that one we just did?
No, it's pretty clear.
Okay. All right. This is probably the hardest, most difficult one. Because you'll start out with GCF and you'll realize there's no GCF. There's no number that goes into both. Or all three. Sorry, all three. Difference of squares. It's not two terms. It's not a perfect square trinomial because you can't take the square root of the first and the last. They're not perfect. Perfect squares. So that one's out. And then a equals 1, bunch of them we've been doing. It's not 1 in front. So this is the a not equal to 1. Do you remember how to approach these?
I forgot.
So you take the first times the last, first times the last. So that gets you
Oh,
to,
that one.
yes,
144.
144. So now what you're hoping for is two numbers that multiply to 144, but add up to 25. I think you said you're allowed to use a calculator. Is that right?
Yeah, that's what I'm doing now.
So it's a little slow, but you just keep dividing until you find ones that work, and hopefully you get one that adds up to 25. It does exist.
Okay, 9 and 16.
Yes. So you're right. You have a choice here. We're going to go 16x plus 9x. You split apart the 25 into the two numbers there.
Okay.
And then do you remember what to do from here?
Um, I keep thinking like try to find the greatest common factor from
Yes.
here.
Of the first
Okay.
two. Yep, the first two.
The first two. That'd be 4, I think.
So 4x. And then that leaves you with 3x plus 4 here.
Yeah.
And then you write that
Then,
over here. Hopefully there's something that goes in between.
plus your positive 3.
Positive 3. Yeah. So this becomes 4x plus 3 times 3x plus 4, or you could switch the order. Doesn't matter.
Okay.
Is that okay?
Yeah.
All right, so let me drag this list down for the next problem. So the identification is really the key here, is being able to know which is which. Can you tell me if this is a GCF? Yes or no, and maybe why?
So that'd be 7. Oh. Would
Is-
not be
It's not, there's no, it's not a
because
GCF, yeah. Okay. Why is that? What is the is the reason?
the 4 and 28 and 49 do not share a greatest common factor.
That's right. That's right. Good. Now, could this be a difference of squares?
I don't think so.
It's, you're looking for two terms for a difference of squares. This one's definitely not that. There's also no difference. That would be another reason. Is this a perfect square trinomial?
No.
So can you take the square root of the first? Can you take the square root of the last?
Yes.
Yes. So that's a pretty good indicator that it's a perfect square trinomial. So the next thing you have to do is determine when you multiply these together, what is the result when you multiply those together?
14x.
14x. And if you double it, you know, it's yet another step. Is that the middle term?
Yes.
Yes. So all of that to say that the answer is 2x plus 7 squared, and that came from the square roots. I know we haven't done much on perfect square trinomials, but that is what you're looking for. You know, square root of the first, square root of the last, multiply them together, double it. Is that the middle term?
Yeah.
Yes, it is. So this one works out nice. That is, I mean, that is it for this one. There's not much more to do. Nothing more to do on this.
Yeah.
Okay, so on to 17. My screen froze up. Hasn't done that in a while. Okay. So last one here on of the ones you sent. So again, that list is really super important to kind of go down when you're working on these. You don't have to write it down, but you have to just have a mental checklist. So this one is, it could look like a GCF, but that 53 is not going to work out. It's not a difference of squares because there's not two terms. Perfect square trinomial, square root of the first is not a nice one. Then same with the last. So that one's out. It's not an a equals 1 since it's not 1 out in front. Looks like it's this last one. So do you remember what to do for the last one here?
Multiply the first by the
Yeah. So 14.
last.
Yeah. 14 times 14, 196. And then you're looking for two numbers that multiply to 196, but add up to -53. And so take a
Okay.
moment, see if you can come up with those.
Yeah, I got to whip out the calculator.
Yes, this definitely one harder to do than just guess and check by hand.
I got -4 and -49.
Yes. So 14x, we'll go -49x minus, well, actually, which way do you see it? Do you see it as -4x or -49x? Which one do you want to put first?
I did -4x.
-4x minus 49x plus 14. You got to find the greatest common factor between the first two.
The 2.
2x. Yep.
Yeah. 2x. And in parentheses 7x. -2.
Good.
And then it'd be +7.
So you've got to get it's opposite sign because you're trying to get to -49x and +14.
Oh yeah.
And
Oh, it's a -7.
just a small little change to your answer, but that is your final answer on that one.
Okay.
Any questions on that?
No, it's all good.
So your exam will be next week sometime, or is it just put off indefinitely?
Probably sometime next week.
Okay.